Welcome back to Pi Academy. Please like, share and subscribe my YouTube channel to get more videos. In the last video, I will discuss about Abel test, and in this video, I will discuss Diritchlet test and some examples. So what is Diritchlet test? If the function f(x) is bounded and monotonic and also f(x) tends to 0 as x tends to infinity, and also there is another function x, that is x is also bounded and integrable, and also a to b x dx is bounded for b greater than a. Then by Dirichlet test we can say a to infinity f(x) into x dx converges. If this condition holds, then we can say a to infinity f(x) x dx is convergent. Now I discuss some examples. Now I show that by Dirichlet test that this integral is convergent for a greater than 1. To show this, let f(x) equal to 1 by log x and ix what is ix equal to cos x. Here f(x), clearly f(x) is bounded and f(x) is bounded and monotone decreasing and also f(x) tends to 0 as x tends to infinity, and ix, where 1 to b x is bounded. This is equal to 1 to b x, that is cos x into dx. Here cos x, therefore sin x 1 to b equal to sin b minus sin 1. Therefore mod of 1 to b sin x dx, mod of sin b minus sin 1, that is lesser equal to mod sin b plus mod sin 1. Therefore it is lesser equal to, this is lesser equal to, then we can say that 5 is bounded, then therefore 5 is bounded. Now by Dirichlet test we can say a to infinity f(x) into x is convergent for a greater than 1, that is a to infinity cos x by log x dx is convergent. Now I show you another example. I consider another example, integration 0 to or 1 to infinity sin x divided by x to the power p into dx. This is also converges for p greater than 0. Now I show by Dirichlet that is this is convergent for p greater than 0. Let f(x) equal to 1 by x to the power p and x, and also let x equal to sin x. Now f(x) is bounded and monotonic and monotone decreasing and monotone decreasing. And also fx, clearly fx tends to 0 as x tends to infinity when p greater than 0. If p less than 0, then fx tends to plus infinity. Therefore fx tends to 0 as x tends to when p greater than 0. And also phi x is bounded since 1 to be phi x dx equal to 1 to be where phi x is sin x dx. Therefore sin x is minus cos x 1 to b, that is cos 1 minus cos b, here b greater than 1, and 1 to be phi x into dx. This mod lesser equal to mod cos 1 and mod cos b. This lesser equal to 2. Then we can say phi x is also bounded. Therefore phi x is also bounded. Now fx and phi x satisfy all its Diritchlet condition. Then by Diritchlet test we can say integration 1 to infinity sin x by divided by x to the power p into dx converges for p greater than 0. Therefore by Diritchlet test we can say this is convergent for p greater than 0. I consider another example. Another example 1 to infinity sin x divided by x into dx. This is also convergent. Here p equal to 1 greater than 0. We know that this is convergent for p greater than 0. Then this is also convergent by Diritchlet test for p greater than 0. Hence we can say this is convergent for p greater than 0. Similarly we can prove this. And I consider now I show by Diritchlet test 0 to infinity sin x by x dx is convergent. Is convergent. To show this, first I write this. Let I equal to 0 to infinity sin x by x into dx. This as 0 to 1 sin x by x into dx plus 1 to infinity sin x by x into dx. Let I1, this is I1 and this is I2. First I show that I1 is a proper integral and then I2 is a improper integral, but this is convergent. First we show I1 is convergent, then we show I2 is convergent. Here I1 0 to 1 sin x by x into dx. This is not an improper integral of type 1 and this is also not a improper integral of type 2. Since limit x tends to 0 plus sin x by x, this is 1. Therefore it is not a improper integral. Therefore we can say I1 is a proper integral. And here I2 is I also prove that 1 to infinity sin x by x into dx is convergent. Therefore I2 is convergent. Therefore I1, since I1 is proper integral, therefore I1 is convergent and I2 is also convergent. Therefore the addition of two convergence integral is also convergent. Then we can say 0 to infinity, that is 0 to infinity sin x by x into dx is convergent. Then you can say 0 to infinity sin x by x into dx is convergent. Now I show another example. I consider another example as 0 to infinity e to the power minus x into sin x divided by x into dx. By Abel test, I will show that this is convergent. To show this, let fx equal to 1 e to the power minus x and 5x equal to sin x by x. Here fx is clearly fx is monotone decreasing and bounded fx is monotone, and also 0 to infinity 5x dx, that is 0 to infinity sin x divided by x into dx. This is convergence. This improper is here convergence. Since this is convergent, therefore by Abel test we can say 0 to infinity fx into 5x dx, that is 0 to infinity e to the power minus x into sin x by x into dx is convergence. And that's all. Thank you for watching.